Hey everybody, the Doritos Locos RX8 is back in the garage, which means we're going to finish up the last few issues. Joey, don't drink that. And start fitting for some very small wheels. Let's go. How's it going, everybody? Welcome back to Make It and Break It, and that's a huge fucking spider. Hold on one second. Alright. That's super terrifying for a car I'm going to be crawling under. Anyway, we're back working today on our Mazda RX-8, our Doritos Locos RX-8 race car, rally car build. And we've still got a few things to do with this thing. The last you saw this thing, we just completed the new engine install. So we have a new JDM RX-8 Renesis engine put in here. It's running, it's driving. It's got some electrical issues. It's showing some misfires in the front rotor. Randomly, a knock sensor error just showed up recently. One of the O2 sensors is showing an error, and I think I know where I screwed that one up. So we've got a lot of stuff to go troubleshoot here, which we'll do for you guys in another video. But it's been a while, and I wanted to get back to some of the new technology type stuff that we want to approach on this channel. Some of the 3D printing and 3D printing tools that you can use. So we're going to take a break from troubleshooting and normal mechanics work and do a little fitment here. So I've mentioned a few times that the RX-8 here I'm going to try and pull off these wheels while we're talking. I mentioned a few times that the RX-8, I want it to become an all sort of a seat time rally car, or a seat time car, which means I can go take it stage rally, which would be awesome next summer, or rally cross or anything in between. The problem is most good off-road rally tires don't come in 17s. They just don't fit. Or if there are some like 17s or 18s or something that'll actually normally fit on this car, they're super expensive. You have to import them from Europe, and it's hard. The most common rally size wheel in the US, if you're gonna run dedicated gravel mud rally tires, is a 15-inch wheel. And so several people make wheels that are suitable for this sort of rally. If you go look at someone like Method, who we're going to look at here in a second, they make the rally wheels for like the Subaru USA rally team. Really good wheels, really strong, really tough. But being 15s, there's a lot of clearance issues. So what we're going to do here today is get these wheels off and then check out and see what we might have to move to get 15-inch wheels to fit. Alright, so we've got the front wheel off here on our driver's side to kind of show you what we're up against. So the RX-8 is a street performance and track performance sports car, which means it's designed to perform well on the street, be fun to drive, and if you want to go take it to a track, it should be able to function pretty well there. So it's working under certain design parameters that don't make it the best off-road rally car. But it's also got some benefits too, and we'll show you what that are. So in the suspension, it is a double A-arm suspension, which means it has an upper A-arm, hopefully you're seeing B-roll right here, a lower A-arm, and then it has the spring and shock setup running from the lower A-arm through the upper A-arm and up into the suspension mount area. So this is a really good setup for street performance. It more fully controls the wheel throughout its entire travel, which means you can do things like control camber and caster and a whole bunch of stuff with the way these suspension arms are set up. And it also takes a lot of the stress and strain off of the shock spring combo, or your coilovers, or whatever you want to call it, because it is not a main part of the suspension. It's not a stress part of the suspension in the same way that McPherson style strut spring combo is on like your WRX, or probably most of the cars that you're used to seeing in like just your standard tuner market. So it's actually a very good setup for control. It could be a good setup for strength. They design these members for the stresses they expect, which is not off-roading, which means I'm probably going to break an upper A-arm here at some point, but whatever, that's racing, right? There are some drawbacks to this. First, it is designed as a street and track performance car, which means it's designed to be running larger wheels. This car, I think, came stock with 18-inch wheels. It could fit 17s if you wanted it to. I think everything would clear just fine, and these brakes are smaller than the brakes that fit 17s on my Scion. One of the main limiting factors of most performance cars in a street and track environment is their actual brake setup. So the front brakes will get hot, you'll lose them at some point during a track day, and so you want the biggest brakes possible in the front in order to stave off that and get better braking performance over longer runs and that sort of thing. So the Mazda RX-8 follows that nicely, in that it fits basically one of the bigger brake setups possible to fit underneath their wheel options. Unfortunately, we're not running big wheels off-road. Standard track sort of performance tires are 17, 18, 19, 20s if you're putting a lot of power down. Off-road world, the power is not the issue. You're going to put down way more power, even in this thing in stock form, than you can probably handle outside of certain professional rally drivers. And so the issue there is fitting the right tire. And the right tire for an off-road setup is much stiffer, it's much taller. And so you need to fit smaller wheels onto your car in order for everything to fit inside your wheel arches and everything else. Your standard rally tire is a 15-inch. There's some rally tires that'll fit on 14-inch wheels and some that'll fit on 16-inch wheels. There's really nothing outside of that for off-road rally. There are some road rally tires that'll fit on 17s, that sort of thing. But off-road rally tires are predominantly 15-inch tires, which means if you want to run the good stuff, you gotta fit 15-inch you gotta fit 15-inch wheels on your setup. You might be thinking there's a problem. Yes, these brakes will not fit under a 15-inch wheel. Actually, the brake rotor probably will. This brake rotor is 320 millimeter or something like that, 330, something like that. So it is about a foot in diameter, little over a foot. But what will actually screw you is the brake caliper back here. So this brake caliper will probably hit a 15-inch wheel at some point. Other problems: that steering rack up on the front here, that is designed to fit under a 17 or 18-inch wheel. That will probably contact a 15-inch wheel at full lock. And then your upper A-arm might also contact your wheel at full lock, depending on where it is in the travel and all sorts of stuff. So what you really want to do here is figure out what you really want to do here if you're taking a car that doesn't have any sort of rally history on it and trying to go put some real actual rally tires on it. You want to go fit up something that'll tell you what's going to get in the way and what won't. So there are a couple ways to do this. First, you can just get a wheel. So we could just get a wheel. Not this one, obviously. We could just go get a Method Racing 502 VT, which is what I like for their rally wheels. We could just go get one, fit it on here and see how it fits, see what it hits, and that sort of thing. But one, that's not cheap, because I don't know for a fact that the Method racing wheels are the best wheels to fit on here yet. There's a couple other manufacturers that make some really good rally wheels. Also, if you're fitting a full wheel like that, if you have huge contact in one area, let's say it's this brake caliper, it may stop you from getting a realistic idea of what else you're contacting elsewhere in the suspension while you're doing that. Such that you might fix one thing and then think you're ready to go, and then, oh crap, here's this other piece, and oh crap, here's this other piece. So what you really should do when you're trying to fit unknown wheels and pieces is create yourself some sort of fitment template. Luckily, a lot of the wheel manufacturers out there create a fitment template for their wheels, and you can just go get them and check them out on your car. So we're gonna go do that today, but we're gonna throw it on with a little twist, because we're not gonna use their template as is. So I'm gonna see you guys on the computer. We're gonna be looking at Method racing wheels. I'm gonna show you what I'm talking about. Okay, everybody. So we're in here. You can see where we're at. We're at the Method racing wheel website. This is one of the two wheels that come in, at least the last time I checked, it's one of the two wheels that come in rally style, which is 15-inch diameter. These are by 7 or by 8s typically. You notice there's a bunch of stuff here about their manufacturer, load ratings, and it kind of gives you an idea of what the wheels clear. And most of the problem is brake clearance, like we were talking about earlier. So these wheels will clear a Subaru WRX 2014 setup. It's the 4-pot calipers, not the upgraded 6 pots or the STI brake setups. Notice where it says will not fit over the OE Subaru STI, which is kind of funny. There's an AP Racing CP6720 calipers. So these are some specific rally style calipers that are super cool, but also very expensive. And it says most brake packages with rotors up to 300 millimeters in diameter. So this is kind of the catch-all for most of us who are not running specific rally brake setups and suspension setups where we have to kind of make it up as we go. Note that the stock RX8 front rotor is a 321 millimeters, so it's probably going to be too big to clear, which is why we're looking at this. And admittedly, this wheel also has a problem where its hub diameter is also off, but we're using this as an example, not necessarily 100% perfect how to do it. But if you go look down, you can see this is basically the only difference here is their the wheel diameter, all that sort of stuff. But you can see they have a basic fitment technical drawing. So if you click that, what you'll get is a link to a PDF that looks like this. So when you're looking at this PDF, you see some stuff over here. This is Method racing wheels. If you've ever looked at like a standard technical drawing, this is all the stuff. A lot of times it'll go proprietary, confidential, usage agreements, things like down here in this very corner. Let's zoom in. You'll see things like tolerances and things like that. So that'll tell you like how they tolerance a lot of their drawings, plus no decimals. Also, let's get really close here. So if we go read some of this, like, 2-place decimals or tolerance to, a 1/10 of an inch, or in metric, a 1/10 of a millimeter. In inches, this is pretty standard. 3-place decimals are plus or minus 5 thou, 2 places are 10 thou, and fractional is 64th. This is all pretty standard machinist type stuff. But what they give you in this case, and a lot of wheel manufacturers will have something like this, is they give you a technical drawing of what their wheel looks like. So in this case, this is the bead locker on both sides here. This goes up, and this is what meets up against the against the hub there where you bolt in most of your wheels. That'd be this face here, and this is your bolting face here. This is your 28, so your 56 millimeter hub diameter. So these are built on 56 millimeter hubs, which is Subaru hubs for those. They're designed for Subaru hubs anyway. And here's the front of the wheel coming out up to the front here, and here's the inside going out all the way out to the back. So how they say to do this is to print it 1-to-1 on an 11 by 17 inch piece of paper. I think that's A3 size scale. Just random tidbits and facts. Then glue it to cardboard and cut it out, and you'll get yourself a template to use. That works fine if you have an 11 by 17 printer. I don't have an 11 by 17 printer. It's not a very common style printer to have unless you're printing a lot of technical drawings, which typically print out on 11 by 17 very well. It all has to do with the spacing of the drawing and being readable on a piece of paper. Anyway, 11 by 17 is pretty standard for a lot of technical drawings. I don't have any of those. So what I did is I took this drawing and created a 3D model of it. So we'll show you that here. All right, so what we've loaded into SolidWorks here, and this is the fitment tool we came up with. You can see it is roughly similar to, it is actually very close to that drawing. This was created in a manner that's pretty common. Maybe I'll do a tutorial on this sort of thing. But essentially what we do is we import this picture, right? We import this picture as a background into our CAD environment, and then use a tool in our CAD environment that actually just traces these lines pretty close with its own software. And it'll give you essentially, it'll give you pretty close to, come on. Yes, I want the fitment tool. There we go. It'll give you pretty close to the outline you want. And then you've just got to go in and massage it and adjust where some of these complex splines and curves go, and it'll give you this piece like this. So what we've actually done is we did this, and we did this for the 502, which is what you see here, and the 501, which is a slightly different offset. It's also a different cost, just to see if it would be different. And then we went and printed a wheel mount tool. So we designed a wheel mount tool. I just gave away the ending here. Which is something like this. So this is a wheel mount tool, which is kind of designed to clear pretty much any hub right here. And it'll go in. These are designed to go match up to your bolt pattern. So these are 5x114, which matches the RX8. It's pretty easy to change it to like a 5x100 if you're doing like my Scion TC is a 5x100, WRXs are 5x100. So if you're doing something like that and want to match up wheels, you can do it like this. And so this will get bolted down using your regular wheel stud sort of thing. And then this slot actually takes those assemblies, or the little fitment tools that we created from the previous one. That would be this fitment tool will actually slide into that slot, kind of like this. So this will slide into the slot and hit up on a little part that we have, and then you can actually have this thing sitting on your wheel and spin it around as a fitment tool without having to go buy a full wheel. So we then threw this into our slicer. You can see some other videos on the channel on that sort of process. Threw it into a slicer, got them printed, and got our pieces. Hi, big puppy. Want to help me fit some wheels? Is that what you want to do? Alright, so once you get your tooling back off the printer, this current V1 setup looks kind of like this. So we have a mounting hub sort of thing with a slot. You can kind of see that slot here, that these wheel fitment tools slide into and hook up against, kind of like that. So you end up with a tool that looks like that can rotate around your hub. So hopefully, I have not test fit this thing yet. So hopefully everything fits appropriately. Let's see. It's a good start. Not the best fit in the world there, but... So you actually just use this kind of tool, and it's not perfect because it doesn't hub center like a standard tool might, or your standard wheels might. It centers on the bolt circle, but for this sort of interference type check, it's really not that bad to do it that way. I did print this out of PLA. It's printed out of white because that's what I had loaded in the printer. Which means you can't really torque down on it super hard. So I wouldn't torque down more than like finger tight on any of these tools, but you can 100% just take your standard wheel nuts like we're doing here, mount it to your hub, and you have a full-blown alignment check tool that'll rotate with you. Unfortunately, one of the design problems with this right now is I don't have a good way for it to stay in the hole. So I'm probably gonna have to get some tape or something like that to hold these in. And we'll see what we got. So that's kind of what happens straight. So what we're seeing is we get a little bit of impact on this brake shroud here, which is not unexpected. This probably would have to get removed anyway. We obviously hit our brake calipers back here. Currently we're clearing, straight ahead we're clearing our steering rack right now. But we have some inconclusive results on the bottom upright mount. So what I'm gonna do is try and fix this thing together a little bit more securely and check that out again. And then we're gonna go take it to full lock either way to check and see if anything changes. All right, so here we're at full left lock. Obviously, some of the parts that contact are not going to contact again, are still going to contact. Things that rotate with the wheel, like the brake caliper, will still contact. But we're looking at things like the steering rack and various knuckles involved there. So those will clear. Hello, Joseph. Nice to see you again. Hello, Bub Bub. Yeah, you gonna kick my cameras all around? Hi, yeah. Can I continue working? Is that okay? And then we'll check full right hand lock. All right, so that's how you do the inspection here. The rear wheel is pretty much the same, except that it, you don't turn it, obviously. You would really prefer to do this at both, at your entire travel, you know, all the way through your travel. So this is at full droop, and then you want to do it at full compression as well, just to check and make sure the stuff doesn't change, or like the wheel gets too close to like some of the suspension pieces in here, something like that. Currently, it doesn't look like our steering rack or our A-arms are really in trouble. Although some of the brake lines may be worth rerouting, but that will probably happen anyway because our calipers absolutely have to change, and our brakes probably have to get smaller anyway, as well as we need to keep in mind that the bottom joint for our upright here, upright, is that what it's called? Our bottom A-arm connection into our hub area It also looks like it's very, very close, and might be worth trying to figure out how to shave off a little bit of space there. So our final inspection results here. Looks like our A-arms themselves are fine, and our steering rack is okay, but we do have to replace the brakes, and we might need to clearance the bottom upright connection, ball joint, whatever the bottom joint is there for this upright hub connection here. You guys are seeing we're very, very close, and that makes me nervous when you're that close. So not too bad, all things considered, for a change here. If you're changing the wheel size so drastically, that's not too bad at all. Anyway, guys, Joseph the Adventure Dog here really wants my attention, so I'm gonna end up this video here. Just want to show you guys how you can take advantage of modern 3D printer technology and a little bit of time on a CAD program, pretty much any CAD program. Yep, hi Joe. And create yourself some really robust and useful tools to attack projects that can be intimidating at first look. So things like wheel clearancing when you don't have a bunch of wheels on the shelf. You can just print yourself a tool, figure out what clearances you actually need, and then adjust your work accordingly. Anyway, guys, I just want to take a quick break from the mechanicking of everything and being a mechanic to show you how to use a little bit of modern, inexpensive 3D printer technology, some CAD work, and create yourself some robust, reusable tools so that you can do things that your car manufacturer never thought you'd ever want to do with a car. Next episode, we'll get back to fixing some parts on this car that aren't working properly, some sensors. Maybe the Adventure Dog, Joseph over here, will join in on those too. He's being very cuddly today. Anyway, I'm gonna end this here for you guys so I don't continue rambling on too long. Thanks for watching, everyone. Again, my name's Andrew. This is Joey the Adventure Dog. This is another Make and Break It YouTube video. If you like this video, definitely hit like. Comment down below if you found this helpful. If there's something more you want to see, if you want me to show you guys how I create templates like this from Fitment guides and that sort of thing, I can show you that. Anything at all, really. Throw it in the comment section down below. If you like what we're doing in this channel, we have motorsports builds like our Doritos Locos RX8 race car build here, and some other stuff, as well as 3D printing videos like this. Definitely go ahead and subscribe and ding that bell icon so you get notified when we put out a new video. So thanks for watching, everyone. My name's Andrew, and I'll catch y'all later. On Joe.